Hey guys, so there is currently this buffer hack making its rounds on the internet, and with that we can simulate with geometry nodes. And there are some tutorials online, but not many. So I thought it would be cool to share with you my project I've did, and in this case I did some terrain erosion, or more or less experimented with it. So let's show you my result. So you see all these particles flowing down the slopes of the terrain and erode it. And there wasn't much information in the internet available on how to do this with geometry nodes, so I came up with some techniques by myself. So it isn't perfect by any means, so feel free to correct me if I'm wrong. But yeah, so I thought it would be cool to share with you my techniques, and maybe you can do with it what you want, take it further. So yeah, let's start with a new file. So here we have a fresh new file, and for simplicity I delete everything except the cube. And now we set up first the feedback loop, and for this I duplicate the cube. One I call the buffer, and the other I call the sim object for simulation, and both need geometry nodes. So this is the simulation geometry node, and the buffer one gets buffer node tree. And the first thing we need to do is we take the simulation object, set it to relative, and put it straight to the output of the buffer node group. And then we kind of do the same in the simulation object. So here we take the buffer object, and now we need to create a switch and put the buffer object also to relative, put it down here in the true input, and our default geometry in the false input. Now we put this at the output, and now the object gets passed around the sim object and the buffer object, and we want it to happen based on frames. So each frame they create like a feedback loop. So we can take, for example, the scene time and compare node, and say that we only want the original object here on the first frame, and everything else gets passed between the sim and the buffer object. So yeah, sorry for my bad explanation. I always struggle to find the English vocabulary, but yeah, I think you get my point. So this is our loop right here. So here we have the initial object, and for this I don't want the default cube. In my case I take a grid to create a terrain out of this. And if we have a look at this, we want to scale it up, maybe like 5 meters. And right now you can see that the buffer object is still active, so we don't want it to be visible. And yeah, so put this in here, and this we put in here. And now to create some displacement, we first want to add some more resolution to my grid. And to displace it, I use a set position node, and I want to only displace the z coordinate. So I take a combine x, y, z. And in here I can, for example, plug in a noise texture and take the factor and scale it down. And also we can multiply to control the strength. Maybe we first subtract 0.5 from it, to put it in a range of minus 0.5 and 0.5. And here we can control the strength. So yeah. First we want to get something that resembles terrain to some degree. And I think this already looks kind of good. And this is the base mesh on which we want to distribute points and then simulate these points. And based on the movement of these points or particles, we want to erode the terrain. So let's quickly call this terrain. Okay. Now the first step would be to create some particles. And for this we can use the distribute points on faces node. And it works on the first frame, but if we scroll through our timeline, you can see that an error appears and it says that it has an unsupported type point cloud, and this is because we create a point cloud right here and pass it to our buffer object, and the buffer object here gives us on the second frame only a point cloud. So we need to pass the base terrain mesh with the point cloud. So yeah, we can simply do this with a join geometry node, and then we also pass the terrain, and now it still gives us an error, and this is because we need to separate the point cloud from our mesh. So here we get the mesh and the point cloud, and we can separate it with the, I think, separate components, yes. So here where we distribute our points, we want the mesh, and also we want to pass the mesh down here. So all these points that are included here, which we get from our buffer, are ignored by the distribute points on faces. So let's have a look. Yeah, still nothing moves. And to see some changes, we can take the scene time, and every frame we want another seed for the distribution here. So let's have a look. Yeah, you can see this. And of course we want also pass the previous points. So we get another separate component, and then we send the point cloud to our joint geometry. And now all these points persist between our frames. So that's exactly what we want. So we let me reorder this. So we can name this here base mesh. This we call previous points, and this we call create points. The next step would be to add some velocity to our points. So let's do this. So for this we want to store a vector on every new point we instantiate. And we can do this with the store named attribute. And here we set it to vector. And this we call particle velocity. And now we can say that we want to move all our points by this velocity. So we need a set position, and then we need the attribute, and we can get it with the named attribute. Here we choose our particle velocity, choose this for the offset, and you have to remember that we here have our previous points, so we want to affect both of them. So we need to join these two. And now I need to plug them in a set position here. And I don't need this connection here anymore. And now, of course, we need to set the velocity. And what I tend to do is to simply store it again. So we don't need to do this, but yeah, in my case, I do it. So if I put a value in here, we should see these particles fall. So yeah. Looks good so far, but right now they have a constant speed and we want to simulate some gravity. So with each frame, the velocity gets added to our speed. So we simply need this velocity we have and add the gravity to it. So, oops. Can do this with a vector math node. And the z value is our gravity. So maybe like this. And now you can see it accelerates. So we need a fairly small value right here. Do like this. Yes. So let's see what happens if we delete the store attribute here. If it works, it should work. Yeah. So we don't need to store it a second time. Yes. So right now all these particles fall and it looks nice and all, but we want them to move along the slopes of our terrain. And now is the point where I need to warn you, because my solution for this problem may be totally wrong, but it worked for my case and I came up with it by myself. So I guess there are more accurate solutions for this. So yeah, feel free to correct me, but let me first explain to you my thought process for this. So let's pick a point we have instantiated. So maybe this one. And imagine it is freshly instantiated and we want to apply the downward force, so the gravity to it. So it should give us this velocity for this point at this frame. And then we look at the mesh, so the terrain, and look at the normal at the point's position. So the normal for this point here should point maybe in this direction here. And then I thought I should create a cross product out of it. And the cross product would give us a vector which should point in this direction. And this, of course, isn't what we want. We want a vector which points maybe in this direction. So we can get this vector if we now take the resulting cross product and create another cross product with the normal vector. So we create two cross products and then we are left with this vector, and this is exactly the direction our point should move. So yeah, maybe totally wrong, and I guess in some edge cases it don't work. Maybe, for example, if we have overlapping terrain, and then it wouldn't work. But yeah, for my case, it worked. So yeah, let's implement this wacky technique in my node tree. So maybe we switch this to a matcap view like this, and then test the node tree again. It works. And we don't want so much density, maybe like this. And it's still a lot of particles, so maybe even lower, maybe like this. So yeah, we have to keep the performance in mind, because this loop we've created here it's very dangerous because it's an infinite loop, and yeah, so we can crash the computer very, very easily. So keep this in mind. Okay, so now to get the normal, we can get it with the transfer attribute node. So we want to transfer the normal from the base mesh here. So transfer attribute, and then we set it to a vector, and we want to get the normal. So like this, and I rearrange this here a little bit, make a little bit more space. Okay, so now here we have the current velocity of each point, and here we have the normal of the surface it sits on. And now we take the cross product of both, and then we take the cross product between the resulting cross product here and the normal again, and then we should be able to plug this in here. And let's have a look. Yeah, they are moving along the surface, but in the wrong direction. So I need to invert this, and I do this with the scale vector math node. I put -1 in here, and now they are moving down the slope, but yeah, there are some glitches, and I found that with this here we can control like the damping of our points. So if I put -0.9 in here, it looks a little bit better. Maybe we need to put more damping in here. Yeah, this looks kind of okay. So yeah, there are some errors appearing, some points move through our mesh, and I guess that's because of my wacky technique. But yeah, it's good. It is good enough for my purpose, and we can work with it. So now we see some points which move away from our mesh, and I thought it would be good to just delete them if they are too far away from our base mesh, and this is fairly easy. Here we have our points, our previous points, and we want to delete them when they are away from our base mesh. And for this we can, for example, take the geometry proximity node and say if the distance is greater than a specific value. So we take a compare node, and maybe I put 0.5 in it for now. Then we want to delete these points. So now they should disappear. So maybe I can lower this even further, like this. Yes. So let's quickly rearrange this a little bit, and I call this delete if of map. Here, this I call set velocity, and here remove the points. And now we could do another thing. So for example, we can give all these particles a lifetime, and this is a fairly easy thing to do. So similar to what we do with the velocity, we store an lifetime attribute. So I call this particle lifetime, for example, and we want this to be an integer. And at the first frame, when we set it, it is 0, and for each frame we want to increment it by 1. So let's do this. So we get the lifetime from the previous points we get from here with the named attribute. And why doesn't it show up here? I don't know, but so I have to type it in by myself. I hope it works. Then I plug this in here, and for each frame I want to add 1 to it. So I call this set lifetime. And similar to what we do here, we want to delete the points if they are if the lifetime is greater than, I don't know, a specific value. So we need another delete geometry node, and then we get the named attribute, the particle lifetime. And now we create another compare node and say if the lifetime is greater than maybe 20 frames, we want to delete the particles. So call this frame delete after lifetime. And now these particles should disappear depending on what value we put in here. So with this I can control the lifetime of the particles. So yeah, I think around 100 frames is good, and then they should disappear. So they are not pooling so much in these valleys right here. So yeah, I think this is the first step. So we created this nice simulation of moving points, and the next step is to displace the terrain depending on the points we've created. Okay, so the idea here is to move down the terrain a little bit based on the proximity to these points. So here at the top we have our points, and here is our mesh at the bottom. So let's get in this node tree. And now we want a proximity node. And here we have our points. And we want to set the proximity node to points, of course. And based on the proximity to these points, we want to set a position for the vertices of the base mesh. So here we set a position, and I want to set the Z coordinate, and I take a combine X, Y, Z. And now we could, for demonstration purposes, simply plug the distance in the Z coordinate, and the result should be kind of wild. Yeah, you see, it's not what we want. So of course we need to remap the distance. So let's do this with the map range node. And right now, the further the distance is, the more displacement happens. So we need to invert it. So the closest it is, the more displacement we want. So I invert it here. And this here controls the influence range of each particle. So maybe put this right now at 0.1. And now it should look a little bit better or not really. And this is because we have to multiply this result with a negative value, or maybe we can put a negative value in here. So maybe like this, a fairly low value is needed for this. And now it should already kind of look a little bit better. Oh, I have forgotten to set this to a negative value, like this. And now you see that it kind of works, but we have to set an even lower value, I think. Yeah, maybe like this. Yeah, it starts to look good, but yeah, obviously there are some mistakes happening, like all these pools here, and we need to prevent these from happening. So the first step I want to do is to put this back in a range of 0 and 1, so we can control it a little bit better with another multiply node. And here we can say this is the erosion amount. And now we want to take the velocity of the moving points into account. So points that are moving fast should erode more terrain, and points that are not moving at all should not erode any terrain. So like these points here at the top that don't move, don't create these pits here. So yeah, how to do this? We simply take the transfer attribute node and transfer the velocity to the erosion amount we have right here. So we take the transfer attribute, and from our points we want the velocity. We can get it with the named attribute. I don't know why it doesn't autocomplete here. So how is it called? Like this. And it is a vector. So set this to vector. And for my case, I simply want to look at the velocity in the downwards direction, so the z coordinate. So I take the z coordinate, and we have to keep in mind that if it points downward, it is negative. So to turn it positive, we can, for example, take an absolute node like this. And now we should be able to simply multiply this velocity to our erosion amount right here. So let's have a look. Yeah, we don't see very much, maybe because we need to increase the factor of our erosion. Yeah, we start to begin to see something. And now the resulting errors don't happen so often. So yeah, you see all these values are forming, and maybe we can increase the frames a little bit to 1000. And I also want to set the base mesh to smooth. like this. Yeah. Oh, why doesn't it move? Because we have to reset it, maybe? Okay. So here you can see that there are still some errors happening. But I think, yeah, for this tutorial I won't go any further, because in my file I also tried to create some sediment that each particle carries, and if it reaches a maximum of its load capacity, it adds to the terrain back. So for example, if these particles move quite a bit on the terrain and they reach the valley here, they deposit some sediment. So we add to the terrain. But maybe you can figure it out yourself. Yeah. And what I also did is to create some age to each of these particles, so they lose some weight, and the older they are, the lesser influence they have on the erosion. And yeah, maybe that's something you can also create in your setup. So yeah, that's a really whack terrain erosion effect. But yeah, it creates some nice results, I think. And yeah, maybe it gives you some nice ideas that you can use yourself. So here's again my other file I've did. And you can see I added a little bit more resolution to this mesh and created quite a bit more particles. And here the green area is where there is the sediment which is added back to the terrain. And some ideas I've not implemented is to create some noise to the velocity vector, so it doesn't give this smooth lines here. And yeah, maybe you can even add some wind by yourself. Yeah, but you have to figure it out yourself. So yeah, I hope you've liked this tutorial. It was quite spontaneous and maybe a little bit too much, too complicated. Yeah, you can comment down below, do what you want, and yeah, see you next time.